If you're looking for news related to Kubecon London 2025, then this episode is for you. Welcome back to the Is It Observable YouTube channel. Today's episode is a bit special because it's going to be related to Kubecon London 2025. If you pay attention, a few weeks ago, Kubecon was happening in London and there was more than 12,000 plus attendees. And as usual, when I go to Kubecon, I bring my gear and I try to do some interviews. Because I did so many interviews, at the end, I will have 3 distinct episodes with different interviews about speakers, maintainers, and I will present a few solutions. In this episode, we will focus on the pre-conference called Cloud Native Projects and Observatory Day and the first day of Kubecon. So I will share a few talks about Dapper, news about Bindplane. I had the chance to meet Kasper that was on main stage for keynote. I also had a major talk about Autoscaling on Daemonset. Very exciting to hear about this. And last, if you never heard about Kedify, which is built by the maintainer of Keda, he will deliver a small demo and present the solution to us. If you enjoyed today's content, don't forget to like and subscribe to the channel. So follow me in London. And another Kubecon. Let's go for London. Today, Cloud Native Projects, a smaller conference, a lot of great talks, and I'm doing a talk, so I'm obviously going to be there, and I'm going to try to do some interviews.
Hey, I am Adnan, and I am the Head of Developer Relations at Bindplane. At Kubecon Europe here in London for this year, I'm actually here with 2 of my colleagues from Bindplane, and we're going to be hanging around the OpenTelemetry Observatory. We're going to talk about the OpenTelemetry collector. If you have any questions about the collector, if you want to know more about OpAmp, so the Open Agent Management Protocol. Bindplane as a company is very focused on the open source contributions back to the OpenTelemetry community. My colleague Andy, he's one of the maintainers of the OpAmp project. He's going to be doing a talk with Evan from Dynatrace, where he's going to go into all of the details and the specifics, specifically on OpAmp, all of the new features that are being developed or have been released in the last year, and also just demoing how it works, showing you how it works, showing you the power of it, why you should definitely use it if you want to do any sort of management of massive fleets of OpenTelemetry collectors. So updates on Bindplane in the last, let's say, year or 2. The main things, well, I'm going to say the big things that have happened is that now we support pretty much any form of infrastructure that you want. You can run Bindplane self-hosted in a VM, you can run it in Docker, you can run it in Kubernetes, all of the other Kubernetes, Nomad, and etc. But you can also use the hosted platform or the SaaS hosted platform. The feature set is the same across everything. It all depends on the license you pick. We recently also pushed out a massive update to our configs, so the actual diagrams of how all of the configuration between the sources, the processor, and destinations look like. Being able to have more than 500,000 collectors managed in Bindplane is a massive thing, and the whole team is super proud of that achievement. Using OpAmp with a collector, communicating with an OpAmp server, using the server to manage your collectors. Up until very recently, the only OpenTelemetry collector distribution that supported OpAmp built in was actually the Bindplane OpenTelemetry collector distribution, which, I mean, that's awesome, but we as a company, we stand by the fact that we think that everybody should build their own distro. You should only use the modules that you really need for your use case. So what we're trying to work and help the community build right now is the op-amp supervisor, where essentially with the supervisor, you have this one layer that sits above the collector that communicates with an op-amp server, and then the supervisor communicates with the OpenTelemetry collector. So that specifically is something that my colleague Andy will be explaining in the op-amp presentation that's happening last day of KubeCon, so on Friday. And that's a really, really powerful thing, because now you can use the OpenTelemetry collector builder and basically give it the manifest, build the collector for what you want, and then use the op-amp extension to get the actual configuration or the open agent management protocol configured correctly. And that's such a powerful thing for those exact reasons, because you're not having to rely on somebody else. You don't have to rely on a vendor distribution to get exactly what you want. For right now, the actual dashboarding that we have, it's pretty much, we're only watching the watchers, so to say. So we're grabbing all of the internal telemetry from the collectors and keeping them in dashboards, primarily to figure out the data flow in a way where whether we're reducing it, increasing it, or how the processors themselves are affecting the data flow. So one thing that I personally like the most is that we have a dashboard overview that says for one particular set of collectors and one particular set of destinations, which you can actively pick, you know exactly on a percentage-wise how much that reduction is affecting your end data storage. Other OpenTelemetry project that we're pushing, that's an open source repository as well, is that we built something called the OpenTelemetry Distribution Builder, which is basically a wrapper for the OCB, so the OpenTelemetry Collector Builder. But the kicker is actually that we're leveraging, essentially building on top of the OCB to literally give it a manifest, and you get a set of artifacts out as output. So you don't really have to do a lot. You're just giving it a manifest, specifying whether you want the ARM architecture or the AMD architecture, or basically whatever else you want to configure, and you get that exact artifact out of it. Which means that if you have a requirement of pushing dozens of collectors to whatever sets of servers, whether there's Windows servers or Linux or Debian or maybe something third, you can build that and get all of those RPM packages, dev packages, whatever packages you need, and just install them right away. And you know that it's the same version that you specified for all of them. You know the update processes. You know exactly what you need to do to update all of them, because you have that one builder tool. That, by the way, also works as a GitHub action, and then you can version your collector, your specific collector as well.
Hi, my name is Manuel. I'm working for a German company called CodeCentric, and I'm one of the guys involved with Daper, not as working for them, but I'm really close with their open source team, and I love speaking about it. So my talk today was alongside Alice Gibbons, who's a customer success at Diagred, and we talked about Daper and cross-cluster, cross-cloud connectivity in a nutshell, basically. What we focused on is if we look into how Daper abstracts things away, like Daper takes away some pain in developing distributed systems, distributed applications. And this is already great for developers, right? Because they all just develop against a common set of APIs of like building blocks for like PubSub, for example, and then they just fire it away, and it's part of the operations team to make sure that this functionality works against, for example, an Azure PubSub or something Amazon, doesn't really matter. But it's still focused around one cluster in one cloud, for example. And we try to show how we can use other technologies such as Cilium to kind of build like a mesh of clusters, for example, to even put in another abstraction layer in there so that you get more freedom in choosing your tools and more fault tolerancy, because you can more easily scale applications across different environments and across different clouds. If we want to think about components and when applications start adopting these components, out of the view of Daper, a component is basically just a set of YAML, as is everything in Kubernetes, basically. And this component, this set of YAML, defines an endpoint for a given building block, what they call it. So if we take the PubSub building block as an example, the building block inherits the information of which building or which PubSub component I'm using, such as, for example, Azure Service Bus and its endpoint, right? If we take it a step further and we think, for example, about Redis, this component would have like, hey, I'm a Redis, and it would have an endpoint, for example, the service in the cluster where Redis is listening, along as its password or secrets or whatever. And if you're now moving this to a different set of implementation, you would change this building block, right? In the cross-cluster connectivity world, if we think about the Redis example, the address where Redis is running on, from their perspective, will always be a local address, right? So it could always be myredis.redis_namespace.cluster.local if we talk about DNS names. But since Cilium is under the hood, it might start rewriting traffic, rerouting traffic and things so that out of the Dapr view, everything is still local, but eventually it could be in a different cluster, in a different availability zone, wherever your other workloads are deployed. So you're getting a complete freedom in how you set up your cluster and how you set up your applications running on this cluster. For sure, this adds a bit of latency, right? I mean, it's network hops eventually, so everything gets the latency. I think the story at that point is that it's not only Dapr, if we talk about this. In this combination, it's Dapr plus Cilium, right? Dapr by itself focuses, for example, on the traces, right? So that you can see the traces and the spans and everything, but it will always be the full cycle, right? I'm not sure, or I'm like, depending on how deep you want to go, this might not be all the information you need. But since Cilium in this example, as the CNI below, exposes you like a different set and a freaking amount of metrics and information and everything you want to go by, so that in your observability tool, you will probably go and combine those two sources to get like the real view of all the information you need to do that decision, like how much latency did this action actually add to your call. But from what I know, they get this question relatively often for like, how can we spread our applications across clusters, or not only across clusters, how can we spread it across clouds? This is obviously depending on the sector the actual customer is working on, right? Like, because sometimes there might be regulated industries where you might have different set of requirements for like where your data live, or like for like high availability. Maybe you're like legally forced to spread your applications across two clouds or whatever, right? So there's definitely differences where you go, but from what I know from the Dapr folks over there, they have this request rather frequently, but then if they have it, it's really going not just cluster to cluster, because that's relatively easy, then it's cloud to cloud for reasons.
KubeCon Day 0, it means Observatory Day, so let's go for that.
Hi there, I'm Bryan. I work at Grafana Labs.
Yeah, my name's Adam Bernot. I am working on an enhancement to Kubernetes autoscaling, specifically the vertical pod autoscaler.
So myself and Adam Bernot are doing a talk Wednesday 5 p.m. and it's titled The Next Generation of Daemonset Autoscaling.
The origin of the talk for me was that I was working with customers on difficult issues with scaling related to collecting metrics. And so we found that in a lot of our customers' clusters, they were trying to collect metrics and getting very different workloads on different nodes across their system. And that was fine for a while. We had an approach where we were taking advantage of bursting in Kubernetes. So we would set the resource requests very low and set the limits very high and hope that they fell somewhere in between. And that worked for a while until it started showing some signs of strain, particularly at opposite ends of the spectrum and scale. And so for some of our large customers, they may have workloads on a single node that were exposing a ton of metrics. And therefore the collector that was collecting all of those metrics was doing a ton of work, but all focused on one node. That, and combined with the static limits, led us to explore other options. And so we looked at vertical pod auto-scaling, which at first was a great fit because it allowed the workloads to scale up and down depending on what was going on in the customer's cluster.
Auto-scaling, many people, when they think about Kubernetes, think about auto-scaling horizontally. But the whole point of a daemon set is that it runs on every single node. So the real question we have is how do you set the CPU and memory requests for a daemon set? Basically, if you have one daemon set, one pod per node, then you only get one request. And what we realized is that one size does not fit all.
We started to see some pain points from that as well. As I mentioned, when the workloads are really uneven, just having one resource request and limit across the entire cluster can cause problems. So it can look like CPU throttling, it can look like running out of memory, or it can look like reserving way too much in terms of resources on other nodes. And so there's several different failure modes that we had to address. And so I thought about ways to improve the vertical pod auto-scaling experience, and eventually settled on the proposal that's up now. It's under Kubernetes auto-scaling enhancement number 7942. And instead of setting one set of requests and limits for the entire workload, the entire daemon set in our case, it divides that up per node. It allows you to get customized requests and limits for each node in the cluster, which really helps manage the uneven workloads.
So the change that we're talking about in this presentation is making the VPA produce individual per node recommendations, so that once your workload settles down, the VPA can tune its memory and CPU requests to exactly what's appropriate for that node. Is this a solution you use for everything? Maybe not. If your workload is highly variable, well, then you're going to have a challenge. You're just going to have to set the request to something you feel is reasonable. And where it does make sense is where your workload is pretty predictable over hours and days, and where it's pretty stable on any one node. So the workload for, let's say, for a bigger node is twice as much as a smaller node. That's where this new technique is going to make sense.
So a lot of people have asked, what do we do if we want to scale by some other kind of organization? So maybe by node pool, or by some sort of node metadata, like how many CPUs are available on the node, or specific node types in different cloud providers. And there are a lot of good opportunities to scale in different ways with vertical pod auto scaling. We're focused right now on just doing the individual per node recommendations, but the way that we've planned the enhancement adds a field called scope to the vertical pod auto scaling spec. So in the future, that scope can be expanded to result in different kinds of behavior. So if someone was interested in scaling per node group, that's certainly something that would be that they'd be able to implement in the future, building on this work. So we're pre-alpha at this point on the release, and so there is a prototype that's Bryan wrote that's available now, and that's referenced in the auto-scaling issue. It's definitely a good thing to go in and play with if you're interested in this, see how it works, and see if you can get the kinds of behavior you want. One fun feature of vertical pod auto scaling is that it is a semi-separate thing from Kubernetes, so you can install the autoscaler on your own. You can install it in a kind cluster. You can install a branch of it in wherever you're running Kubernetes, and play around with it in your own environment. So there's some good opportunities to play there. And tweak the code if you want, and see if you can implement a different version of what we have that better suits your needs.
Day one for Kubecon. I think there's a lot of keynotes related to observability, so I'm very excited. So let's go.
is Kasper. I'm a developer advocate at Zero and one of the co-chairs of Kubecon Europe. So this time I will be talking about observability, and I think we've sort of seen like people are starting to adopt OpenTelemetry, and I think people are starting to realize that there's real value in like correlating signals, the different signals like log, traces, and metrics. So I think this year will be the year of OpenTelemetry, and hopefully we'll also see OpenTelemetry graduation, doing like the full graduation. I think the process is very close, but I really hope to see that it's going to graduate very soon. But the keynote is really about like trying to explain and tell people how easy it is to get started with OpenTelemetry. I will do a demo using the OpenTelemetry operator, showing auto instrumentation, how easy it is with, to do auto instrumentation without touching any of the code. We'll do the demo about that, and then I will also talk about Percies for dashboarding on monitoring as code. It's a really nice sandbox project within the CNCF, and I think we're going to see a lot of traction now around Percies. Vendors are starting to adopt Percies as a standard, as a way of standardizing dashboards. Yeah. And I think that's pretty cool. So I want to showcase how easy it is to get started with that as well. So I'll be showcasing the Percies operator, applying a few dashboards and showing that on stage. And talk about platform engineering is also part of like this journey. Like bridging observability and platform engineering is really that's really some interesting value in there. But I really want to showcase that this is the future that you are also able to do this very, very soon. You can of course try if you're on the bleeding edge, go ahead and play with it, or maybe use one of the vendors out there that are currently supporting Percies as it is right now, because there's also solutions for you if you are with one of those vendors. There will be a QR code at the end of the presentation tomorrow, and that will include a link to my GitHub repo, so you can also go in and find it on Kasper Nissen on GitHub. That will be a Kubecon demo, and it should be fairly easy to find in there. And there's instructions for how to set up everything, try it out yourself, and just start learning OpenTelemetry and Percies.
Czech Republic, and I'm maintainer of Project Keda. I'm with the project since the beginning, and recently we started a company which is called Kedify, where we provide enterprise features on top of Keda. We still support the project and bring more enterprise features to our customers. Keda is still being used as the core for the autoscaling. So Keda is good for a lot of use cases, but if you deploy applications and try to autoscale them in your cluster, the autoscaling part is just the single point of the whole picture. So we are trying to add more enterprise features that you need in more complex environments. You, for example, need more real-time data, you need more aggressive scaling, etc., etc. So Kedify is an extension on top of Keda, so we try to provide external features on top of Keda, but still provide the same capabilities like Keda does. Our main feature at the moment, which we added, is HTTP-based scaling. So you are able to scale your applications based on HTTP load in real time. You are also able to scale those applications to 0 and not lose any request that is coming to your application. How do we measure the load, and how do we handle the actual metrics that are coming to the HTTP traffic? This is a good question, because this is the important aspect of the whole story. Maybe let me start with the traditional way how Keda scales, like most of the traffic. We are trying to, with Keda, if you use Keda, and for example use Prometheus, you are fetching some external metrics that are not directly bound to the actual load. So the actual applications that we are about to scale is responsible for the data delivery. But if you think about HTTP traffic, it's a bit different, because HTTP traffic is something that is being pushed to the application, so the application needs to receive the data. It is not responsible for pulling the data itself. So the real-time aspect is more important. And when we were trying to figure out how to do that properly, we were trying to overcome the problems that with introducing too much additional stuff on top of Keda in order to help you with scaling HTTP services. So in short, we just intercept the traffic. So you define your traditional application as you would do the usual way. So you would deploy your ingress, your service, your deployment. And what we do in the traffic flow, we inject a small proxy that collects the data in real time. So all the traffic is going through this small proxy. We send the data about the metrics to the KEDA in real time. We push them directly there. And this proxy is also responsible for handling the connections when we are scaled to 0, so we don't lose any traffic. In order to provide a better observability monitoring solution at the moment, we collect a bunch of metrics about the workloads, but this is something that it's on our roadmap for the future, because I believe that because KEDA has an overview of a lot of stuff that's happening in the cluster, we have all the metrics. So ideally what we would like to do in the future is to use these metrics to predict some load that's coming in the future. So we can see some pattern in that and then predict the load. But actually we have also OpenTelemetry scaler that utilizes OpenTelemetry metrics, because the traditional setup with KEDA and one of the most popular scalers is Prometheus 1. So every application is exposing Prometheus metrics. So you scrape those metrics to Prometheus, and then KEDA scrapes those metrics from Prometheus again, and you scale based on that. And we develop a scaler which is called OpenTelemetry, and we deploy OpenTelemetry collector in the cluster, and we directly fetch those metrics from the individual workloads and send them directly to KEDA. So we are skipping the Prometheus in the flow, which is, it has benefits because you don't need external solution. It's more performance, more real time. So this is also another feature that we did at Kedify. We have also additional things that we are working on, especially around optimizing the cluster autoscaling part, because Carpenter cluster autoscaler is great tools. We don't want to replace it, but we would like to help it to scale a little bit faster, because scaling out nodes, creating a new node, Kubernetes node, it takes significantly longer than scaling up pod. And those autoscalers, cluster autoscalers, are reactive, so they just react on the demand coming from the pod. But we would like to use metrics the same way they are used in KEDA for scaling pods, to feed those metrics to Carpenter or cluster autoscaler, to tell it in advance that, okay, there is some big load coming, so you should better start preparing some nodes. So we are working on different integrations around this area. So this is the reason why we started Kedify, to use KEDA and additional tools and build a solution that will help you in a larger scale when you have more traffic, more real-time stuff, and more advanced features. So to introduce our platform, so for Kedify we also have like this unified management console where you can manage your KEDA installation across multiple clusters. In here I have two clusters, AKS, which is currently down, and K3D, which is running on my laptop, and I will show it in the demo. We can use it to manage the installation, to see some metrics about what KEDA does, how it performs. In the future, we would like to bring more metrics here and do like the stuff I discussed before, so the predictive stuff and this kind of telemetry data. And I will use it to create a scaled object and to show you the HTTP scaling in action. So before we start, I will show you the actual application. It is in this console. As you can see, there is running a single replica of an application. It is a very simple one. It is a deployment. You can see traditional deployment. And it is a simple application that just responds to HTTP request. And with some artificial delay, it responds back. So it is a deployment. It is a traditional service that is pointing to this deployment. And finally, we have an ingress. I'm running on K3D on my laptop, so the host header or the host is specified like that. And I will use host headers to point to this actual service. So in the bottom terminal, we can see my commands to execute the request to this application. And we can see that the application was able to respond back 200 OK. So this is without any autoscaling. And now I will autoscale this workload. So I will create a scaled object. We can use this wizard that we have. We can also use traditional YAML files. So I will select the workload, the HTTP server I have. I have set the minimum, maximum replicas. So we will scale to 0 to 10 replicas. I will tweak the settings a little bit so we see faster scaling. It's good for demo purposes, so I will tweak the settings a little bit. And finally, I will add a trigger. So I will add the HTTP scale trigger that we have. It was able to identify the service that is backing the deployment, the port, and it will suggest me the host. So this is the host that we use for the application. Here we have the important part, which is scaling metric. We have two types of scaling metrics for HTTP traffic. One of them is request rate. It basically tells us it measures how many requests in a second is coming to the application. So here we can, for example, specify 10 requests per 1 second. It means that if there are 10 requests, it's single replica. If there are 20 requests, 2 replicas, 30 requests, 3 replicas, etc., etc. The other metric is concurrency, and this measures the number of open HTTP connections to the workload. This is more spiky, so you can see like the spike of client connecting and disconnecting. Usually the scaling metric is better because it uses average over some time. And the last thing is the traffic autowire. So when we deploy this scale object, we will automatically reconfigure the traffic in order to be able to scale the application. So I will deploy this scale object, and in a few seconds, we will see that this application will be scaled down to 0 because there is no traffic. So this is the setup that we have. We have our ingress setup, the green part, the service, and the deployment. And once we deploy the scaled object, we reconfigure traffic to go to the Kedify proxy. It's an envoy-based proxy, very lightweight, and we use it to get a real-time overview of the traffic that is flowing through our application. This is by default deployed by the namespace. And the second thing it does, it's traffic shaping and traffic reconfiguration. So when the application is scaled to 0, the Kedify proxy will send the request to the interceptor component, which holds the incoming request, tell Keda to scale the application out to at least 1 replica, and once the application is scaled to 1 replica, it will forward the request. Once the application is alive, we dynamically change the traffic, and it goes from the Kedify proxy directly to the application. So it is not going through the interceptor component, but it's going directly to the application. The envoy is very lightweight, so there is no much delay. So let me check the deployment. As you can see, the application has been already scaled to 0 because there is no traffic. And the application, the ingress has been reconfigured automatically. So we can see the ingress has been now reconfigured to point to our Kedify proxy. Now, if I create the same request to the application, after a short delay, which really depends on how fast the application is able to spin up, will respond back to my application. I'm running on K3 cluster, so it's a little bit slow, but as you can see, the request has been processed and it hasn't been lost. So, and finally, if we send right now we will generate 10,000 requests, and it will auto-scale the application to 10 replicas.
That's it for today's episode related to Kubecon Europe London, the first episode. In this episode, I was really excited to see Kedify. I like the fact that they have a scaler based on concurrency and throughput with adding this proxy. I think it's really relevant. So if you have the need of scaling based on load, I think Kedify makes a lot of sense in that direction. The other thing that I was also liked, which is part of Keda, is the open telemetry receiver or exporter to Keda, so Keda can take decisions directly at the source without waiting to be stored on the backend. But out of Keda, I was very excited about the talk about autoscaling. I think autoscaling Daemonset for few use cases makes a lot of sense, and this enhancement proposal I think makes a lot of sense and could help us in our cluster. If you enjoyed today's content, don't forget to like and subscribe to the channel. So see you soon for another episode.